Thank you everyone for joining us. So as you can see on the main slide for the COP26, we have an event around our engineers ready for the challenge, the sustainability piece. So this week COP is coming to a close. Climate change and sustainability are top of the agenda, and rightly so, and hopefully will remain top of the agenda. Engineering, of course, plays a crucial role in how we're going to tackle those issues, sustainability issues that we have, carbon aspects and everything else. Engineers, of course, are involved in the design, the manufacture and use of products, processes and solutions all around us, both the current ones and the future ones, which of course we're going to mention about during this session, enabling the engineers to have a huge impact on our carbon footprint and the sustainability potential. So in today's event, we will look at ways in which priorities are going to be evolving for engineers, considering what we can learn from the past, what we need to improve going forward. To look at the past, present and future, we have, and I'm pleased to have, the four panelists to present to you. But before introducing you to them and them to you, we'd like to get your thoughts on a couple of questions. Before I read out the questions, I just realized I forgot to also let you know that we are recording the session, so I hope that's okay for everybody. So the first question we have for you is, which of these applications of engineering skills will be most impactful? Just realized all the pictures are covering the bit aside, in helping to tackle climate change and achieve net zero carbon. There we go, there's the poll. I'm going to see if I can I right click on this as well? Oh, I can. Okay, so I'll give you a couple of minutes to submit your answer. Panel, I think you're able to answer it as well if you wish. Lauren, did the results of the poll come out? Have we got everyone's answers in? Or not?
Almost.
Almost.
Yeah.
It's a big question. So a few thoughts of what you might want. We go for the, well, I guess we're waiting for the answer. So the next question is going to be in the text box. So get your fingers warmed up and have a think of that next question. Shall I go to the next question, Lauren, or is the poll going to pop up? Cool. So the poll is going to close. Okay, so a slight margin with energy, followed by cities and built environment, and then you can see the joint ending, the other piece there. Interesting ending in reversing deforestation, not at all, but I guess it depends on the bigger impacts that you think there are going to be. So really interesting there. I went for energy, by the way. I don't know what the rest of the panel kind of went for. Just thought I'd disclose that. So the next question, this requires you to put it in the chat box. So if you get ready on the chat box, start typing in, and if you already have an answer for it. So the question we've got for you is, what factors do you think engineers have to consider now that they didn't before? Okay, sustainability of materials. Pace of climate change during design life. I guess in addition to that is the pace of innovation during design life, that moving incredibly quickly. Enabling everyone access, life cycles of materials, so lots on life cycles. The impact in new buildings can have on the community. long-term impacts of supply chain. Interestingly, that's something that came up in the first module our students recently did. We had Waterman Group came in. We're talking quite a bit about the long-term impacts of supply chain and considerations around supply chain, as well as the materials used. I know, Hannah, for British Land, materials gets spoken about quite a lot, and also with the redevelopment of Canadawater, what can be reused and not, and the impacts that has. Acceptable risk in a risk-averse culture. Interestingly, the sort of the wood or timber use in structures also came up there, and I know that's an interest piece for you as well, Julie, isn't it? The insurance and other considerations around timber.
Yeah, no, that's right. It sort of links really closely. Yeah, really good points.
Cool. Right, I will stop it there. So thank you very much for your thoughts on that. Several of those come into some of the elements that the panelists we have thought of and will think of as we go into their presentations. So as an introduction to our panelists, I'd like to thank Sarah, Hannah, Julie and Roseanne for joining us. I'm going to ask you to introduce yourselves, a little bit about what you do. So starting with Sarah, if you could say hi.
Hi, I'm Sarah Kuklewicz. I work at the Brunel Museum in Rotherhithe. I have an MA in Classical Studies and I'm currently studying engineering with the Open University. So I'm interested in both engineering now and historical engineering.
Thank you very much. And Hannah?
Hi, I'm Hannah Farraha. I'm a project director for British Land. British Land are one of the leading property companies in the UK, and we own, develop and manage property assets throughout the UK with a particular focus on mixed-use campuses in London, of which Canadawater is one, and that's sort of the main focus for my role at British Land.
Thank you, Hannah. And Julie?
Yeah, hello everybody, really great to be here. I'm Julie Bregula. I'm a civil engineer by background and I lead on project-based learning at TEDI-London, and so I'm the main industry link with developing projects at TEDI with the TEDI students and staff.
And finally, Roseanne.
Hi everyone, my name's Roseanne and I'm a student at TEDI-London and doing the Global Engineering Design degree.
Thank you, Roseanne. I just realised how rude of myself, I didn't introduce myself as we started. So I'm Steve. I look after the industry engagement at TEDI-London, work closely with Julie. So going to start off with the presentations. Thank you all for introducing yourselves. We'll get to know a little bit more about you as well through your presentations. Just to make a note as well that we'll take questions at the end of the presentation. So make a note of any of the questions you've got, keep those to the end. We can have a bit of a discussion and Q&A at the end. But to start us off, Sarah.
Hello. So I'm going to tell you a little about the Brunel Museum and the family it celebrates and touch on their relevance to engineering today. So the Brunel Museum is based on, well, above, the site of the first tunnel dug through soft ground under a navigable river anywhere in the world. The tunnel was built between 1825 and 1843, Mark Brunel being the main driving force, with his son, Isambard Kingdom Brunel, as chief engineer for some of the project. So before this, tunnels that weren't through rock were cut and cover. This means that you knock down anything that's above where you want your tunnel, you dig a ditch, you put whatever you want the tunnel to hold into that ditch, so train tracks for instance, and then you cover it back over. This method has some shortcomings. You can't use it to tunnel under anything you'd rather not knock down. You can't go under tunnels that already exist, and you can't go underwater, unless you're willing to move the water first, as an ancient queen of Assyria is said to have done with the Euphrates. Now, Mark Brunel was a renowned inventor and engineer, and whilst working at shipyards on the south coast, developing an early version of a partly automated production line for tackle blocks, he noted the holes made in the wooden ship hulls by the naval shipworm Teredo nivalis. In an example of biomimicry or nature-inspired design, he was inspired by this mollusk to dig directly where you wanted to go, to tunnel through softer materials instead of removing everything on top and coming in from above. These explorations led to his idea of a tunneling shield, making progress through the ground and then excreting the waste as you go. His first idea was circular and steam-powered and looked really similar to a modern tunnel boring machine, but, you know, steampunk and Victorian. Unfortunately, this just wasn't practical to build at the time. So the compromise he came up with was a rectangle of cages with a miner in each cage to do the digging. And you can see a model of this apparatus at the Brunel Museum. So Mark found investors and was able to use this new technology to create the first tunnel under the Thames. Mark's son, Isambard Kingdom Brunel, who I'm sure you're rather more likely to have heard of, became chief engineer on the project when Mark fell ill. This was Isambard's first lead on a major project, and very nearly his last, but that's a story for another day. The tunnel, though never used for its intended purpose of providing a route for horses and carts across the river, was eventually a success, and you can travel through it today if you take the overground between Rotherhithe and Wapping. The Brunels achieved fame as a family of engineers, with people noting that when young Isambard's older sister Sophia was also inclined towards engineering, though that wasn't something she pursued as an adult. You might think that with what was shaping up to be an engineering dynasty, Henry Mark Brunel, Isambard's son, was also an engineer working on a variety of projects, including Tower Bridge. So you'd think that they must have all had the best engineering education available. And whilst that was true for later generations, so Isambard, who as well as learning from his father, was sent to France to study. So engineering education in the UK was sorely lacking in the early 1800s if you wanted to understand the theory and specifically the mathematics behind what you were doing. So major engineers at the time, such as Thomas Telford, held that deductions drawn from theory were never to be trusted. So Mark was not of the same opinion and sent Isambard to France to learn the maths. And then he was apprenticed to a watchmaker to learn the mechanical and precision aspects of engineering. Because one difference between engineering then and now is that we are a lot more specialized. When it was a new field, there wasn't really such a thing as specialization. However, there is no one true way into engineering, and there never has been. So Mark's story was somewhat different. Mark's family were yeoman farmers in Normandy. His mother died when he was 7, and his father was very traditional. He expected Mark to go into the clergy or law and was absolutely unwilling to accept alternatives. However, when distracting Mark from the carpenter's shop or the wheelwright's yard proved impossible for his father, he sent the unruly 8-year-old to military school. He happily studied mathematics, but he had no facility for Greek or Latin. His father tried again by sending him to seminary to study to be a priest. Mark was happy to take drawing and woodworking lessons. These he was interested in, but he was far more fascinated by new practical tools than by religion. He once pawned part of his uniform to buy tools, which contributed to him being sent home as having obviously no vocation for the church. So to a practical farmer, Mark's artistic, mechanical, and musical predilections were considered useless gifts. Thankfully, a cousin who had been in the Navy suggested that as a route for Mark and offered to take Mark into his home in Rouen. Now, his father grudgingly gave permission for the boy to study nautical science, and a new chapter of Mark's life started. Mark managed to impress the right people, and a few years after embarked on his 6-year naval career, So for context here, the French Revolution got underway while he was at sea, and the France he returned to was quite different from the one that he'd left. As a known royalist, Mark ended up fleeing France for America, where after some adventures, he was finally able to work as an engineer, apparently becoming chief engineer of New York. He ended up in the UK, partly for love, and partly due to a clever idea for machinery dreamt up at a dinner party hosted by none other than Alexander Hamilton. So, as you can see, a lot of his ending up as an engineer was luck. It was meeting the right people and making the right connections, though there was also talent and a lot of hard work mixed in. But engineering wasn't his first career. He didn't have supportive parents, but once he discovered that engineering was a thing and was a thing he wanted to do, he pursued it and he changed the world in the process. Imagine where we would be if networks like the London Underground couldn't exist because you couldn't cross underground tunnels and you couldn't go under rivers. It would change the major cities of the world in a huge way to not have that technology. So as a career changer myself, I find his story particularly inspiring because not all potential engineers realize early on that it's even an option to become an engineer. But that doesn't mean that once you do realize, it can't become a reality. So I have so much more I wanted to say, but I should make some effort to keep to time. So please ask me about examples of the secular economy in Victorian Britain and societal changes as civil engineering went from a new discipline to an established career path. I'm also happy to talk, I warn you, at length about Mark Brunel and his wife Sophia. So you can ask me here or on LinkedIn or come to the Brunel Museum for a tour. And yeah, please do ask me questions. I will happily answer them. And if I don't know the answer, I will find out.
Thank you very much, Sarah. Everybody will come back and get some of those questions from the audience at the end. But for now, I'd like to hand over to Hannah.
Great. I've got a few slides which I'm going to flick through, so I'll probably flick through them pretty quickly and try and keep to time. But what I'm going to talk to you about today is our approach to sustainability and our pathway to net zero carbon at British Land, and show how we're implementing that in a real life example at the Canadawater development. So if we just flick to the next one. I think it's really important as people working in the built environment to understand what our impact is. So I always come back to the fact that 40% of all global emissions come from buildings and construction. So sustainability has always been a really important thing for British Land, and even more so now, and we really recognise our responsibility to contribute to reducing carbon emissions and creating a climate that's sustainable for future generations. So if you just look to the next one, last year we launched our 2030 strategy, which sets out our pathway to getting to net zero carbon by 2030. And that has a number of different targets in it associated with environmental and social responsibility. And today I'll just touch on the environmental targets. And the key ones there are about reducing our embodied carbon, so the carbon associated with the materials in construction and buildings, and our operational carbon, which is all of the carbon emitted as a result of the operation of buildings, so the heating, cooling, lighting, etc. So in terms of embodied carbon, we've set ourselves a goal to reduce the embodied carbon in all of our new developments by 50%. And we've set a target of reducing our operational carbon by 75%. On top of that, we are putting our money where our mouth is, and creating an internal carbon tax on ourselves. So we tax ourselves £60 a tonne on all residual embodied carbon in our developments. And we use that to help retrofit our existing portfolio, because we have lots of buildings that are already in operation that we manage, and typically those are much harder to make net zero. So we use that money to retrofit those developments and also to offset into certified offset schemes. So we think our targets are quite ambitious. And if you just flick to the next page, this is just an example of what the 50% reduction and the 75% reduction actually mean. And we've set carbon targets for both operational and embodied carbon, which are underpinned by sort of industry guidance, best practice such as LETI and REBA. So if you just flick to the next one, another really key part of our pathway to net zero is making sure we have transparency and accountability. And I think that would be something that would be great to come out of COP26 as well, making sure we have transparency and accountability on a national and a global level as well. So we publish detailed sustainability accounts every year, and that is to track our progress to how we're meeting our targets to 2030. And we hope that this becomes sort of industry standard and helps to push for policy changes and that sort of thing as well. So next slide, I'll just give you a very brief overview of the Canadawater Master Plan, just to explain what we're doing there, and then I'll take you through some of the sustainability aspects of Canadawater. So Canadawater is a 53-acre master plan, which is about 40 football pitches, I believe, where we are creating a brand new town centre, and TEDI are part of the very first phase of that, which is super exciting. And we're really trying to become one of the most authentically sustainable urban regeneration schemes in the UK. We sort of feel that there's lots of talk out there at the moment, and we want to make sure that we're backing up that talk and being really authentic and genuine in what we're doing at Canadawater. So next slide. As I mentioned, 53 acres. So it's one of the largest and most significant development sites in central London at the moment. It will consist of between 35 and 40 different new buildings, which we're building out over the next 10 to 15 years. So it's a really long-term development. And in total, it will cost around 4 billion. If you move on to the next slide, just breaking that down into a little bit more detail. So we're aiming to deliver around 3,000 homes, which will house roughly 7,200 people. We've got 2.5 million square foot of workspace, which will bring about 25,000 workers to Canadawater every day, and 1 million square feet of places for people to shop, eat, drink, leisure and community spaces and educational facilities. Next, so that's a very whistle-stop tour of what we're doing at Canadawater. And in terms of our sustainability approach, we're really trying to make sure that sustainability is ingrained in every single decision that we make, and that we're taking a really holistic approach to sustainability. And that means really pushing for bolder innovations, deeper partnerships with our design teams and our contractors and supply chain, and really holding ourselves to higher standards. If we just flick to the next one, I'll just run through a couple of examples of what that actually means. So from an operational energy point of view, we're implementing a low carbon, all electric energy strategy across the whole site. So essentially what we're doing is we're creating a bunch of mini ambient heat networks. So every building will operate as a heat network in its own right. And we're using technology that's been widely used in Scandinavia for some time, where we use air and water source heat pumps to create the energy, and then we pump it around the buildings at a low temperature. So it mitigates the losses of having high temperature networks, which is quite typical at the moment in this country at least. And it also enables us to share waste heat between different uses. And an example of that, if you just flick to the next page, is plot A1, which is the building you can see there. Yep, perfect. With a residential tower and an office building next door. And essentially, we've been awarded a sort of industry first credit from the BRE for our system, which takes the waste heat from the office building and uses it to heat the residential homes. And we're trying to roll that out across Canadawater wherever we can. Next slide. As Steve mentioned, and as a lot of you guys mentioned in the chat in response to those early questions, materials innovation is really, really important. Looking at ways we can use new and different types of materials or adapt traditional materials to reduce our embodied carbon. So we were one of the first people in the UK to use what's called earth-friendly concrete, which essentially removes all of the cement, which is the carbon-hungry element of concrete. And that yielded some really amazing savings. So 240 tonnes of carbon emissions, or 45% compared to what a traditional piling mix would be. And so that was just using it in groundworks, and now we're looking at how we can do that, similar approaches in superstructure as well. So if you just flick on to the next slide, this is another example of an innovation where we're working with a contractor really early in the design phase to implement low carbon concrete cassettes into the superstructure. And this has resulted in an 80% reduction in embodied carbon, 100% reduction in cement, and a 40% reduction to deliveries on site. So really, really helping to drive a reduction in our carbon emissions. And it also creates a really flexible design, which means that the buildings can be adapted over their lifetime, which is also really important. Next slide. So we can't get anywhere on our own. We can't achieve our 2030 targets on our own. So we're really trying to partner with leaders in the industry as much as we can across our projects at Canadawater. So an example of that is one of our projects is being part of a program with Innovate UK, where we sort of partner with an academic from UCL, and they work with us to understand our pathway to net zero and help us to develop tools for how we can reduce our carbon. So it's really pairing up interesting institutions and leaders in innovation with our design teams and with our contractors to try and share as much knowledge as we can across the industry and across education facilities. And I think that was, I've got one further slide just in terms of some of the challenges that we face. So some of the things that might be interesting for you guys to have a think about. So what we've found is that innovation is really moving, and there's lots of innovation, particularly in terms of materials and energy use. But there's at the moment a bit of a misalignment between building regulations, planning policy, and industry best practice. So we're doing lots of work on embodied carbon, but there's no sort of regulation around that at the moment. We think that it's going in the right direction, but we're really keen to make sure that there's a consistency of approach across all contractors and developers and design teams. Materials innovation, Steve and Julie alluded to earlier as well. There's some challenges with insurance and regulatory markets keeping up pace with innovation. Operational carbon, again, policy not necessarily keeping up with what we think is best practice, and getting some more transparency on offsets between both the public and the private sector. So that's it from me. I hope I wasn't talking too quickly as we went through that.
Hi, Hannah, that was great. Thank you very much. It was really good to hear all that. Oh, it's nice to kind of see that the Printworks building as well, which is using
Yes.
pre-existing structure piece, but I know there's a bit of change that you need to do in there. So it's interesting getting that balance of sustainability, isn't it, in there? So keep your questions for Hannah until the end. I know I have a couple of questions, but I hope you do as well. Next, Julie.
Thank you. Yes, hi everybody. I wanted to start to really just sort of maybe sort of kickstart a little bit some of your thinking and sort of get our discussion going. So we've really heard from Sarah about, you know, what engineering was like in the Brunel era and you know, just major innovation and just the amazing engineering feats that we've been seeing. And then really then right on to Hannah and Canadawater. And I will be picking up on some of those strands as well before we hand over to Roseanne to sort of talk a bit about, you know, what will happen next in the next generation. But, you know, some examples here I wanted to maybe just sort of start making you think about, you know, what might have changed and where maybe things come round in circles. So here what you see here is these guys who, you know, in that time was really absolutely how you transported timber from the sawmill and you use the current of the river and these guys guided the logs down the river and made sure that they were then getting to the sawmill for further processing. This has completely disappeared. We now move our timber with really energy intensive trucks and we move them to places. And actually what we're finding, especially next to the River Thames, is actually transporting by river is having a real come round again, because, you know, everybody starts realizing that using the actual current of the river and the energy that provides is actually a much more sustainable way of transporting goods. So you'll see lots and lots of barges going up and down the Thames, for example, transporting goods. Next slide, please. And, you know, and another one of those jobs, you know, that, you know, the world was unthinkable without it. And yet none of us will actually remember ever having spoken to a switchboard operator to actually connect an incoming call to the person you wanted to speak with. It was, you know, huge amounts of technology and making this happen completely gone from our everyday lives. Next slide, please. And here are some other sectors which we still know of, but we know them completely differently, right? So to the left, we've got journalism or newspapers, you know, on a real transitional journey. You know, very rarely do people buy newspapers now. You know, it's just a completely different way of getting news to people. And we've just saw the picture that Hannah put up and Steve mentioned, which is the old print works, you know, again, a building that is no longer used. You know, news get to people and to us in a different way. And the other one, and again, for us in different generations here on this meeting tonight, you know, music has changed completely, the way we listen to it. And that's been a constant change, you know, so, you know, most of you might not even know what this sort of stuff is in the middle of this page, which is like a cassette, you know, so again, you know, huge changes in technology, and also a way of actually people enjoying music still exists, but we enjoy it in a completely different way. And then, yes, the times on the right where somebody went to a store to get a videotape, to then get it out, to watch it at home and then return it and get another one. As a company, Blockbuster's completely disappeared because we're streaming. It's a completely different way of actually doing exactly the same thing, which is looking at movies and programs that you'd like to watch, and that's very different. Next slide, please. And then these are sort of some jobs that, you know, are predicted to actually disappear, you know, so the postman, again, traditional mailing has got many things about it, but, you know, again, you know, on the verge of disappearing. Same with the librarian, you know, the way we access information and get information very different to what we used to do, and how we actually get from A to B. Not that anybody has traveled this last year, but, you know, again, the travel agent, the way that you can search for optimized flight routes, the way that you sort of think from getting to A to B, is just like we're in a real time of transition. And so next slide, please. What does that mean for engineering and the skills of the future? The pictures I've shown you here are pictures of what an engineering office would have looked like anywhere in between the 1940s to about the 1980s, when actually other ways of drawing, of producing drawings, of getting engineering information transferred between teams and between clients. People had these huge offices with these huge drawing boards, having to create these drawings and move them about. On the right here, you see an actual picture of the classroom of people learning how to draw. And, you know, and Roseanne will maybe pick up on this in her talk, but, you know, she certainly is nowhere near a drawing board. All of this is happening in a completely different environment, and it's happening with alternative means, which tend to be digital. And yes, Steve, very right, not one female worker in sight there at all. Not unusual, I think, if Sarah were to look at this picture from a Brunel perspective in mind. You know, girls were very much a rarity there as well. Next slide, please. I'm nearly coming to the end because I really would rather you, very good, yes, Fiona, yeah, not very friendly for shorter people, absolutely. You know, so again, this is sort of what offices in engineering look like now. Yeah, we have got flexible spaces, we work with computers, we have more space to have social space because actually we're communicating in a completely different way. Next slide, please. And you know, Canadawater, if you just look through the lens of Canadawater as to what that means, when Canadawater first sort of entered our psyche, which is the home of TEDI-London, and of course it is also the sort of where the Brunel Museum is located, and also where Hannah has spoken about the Canadawater initiative, which is going on in the next decade or so. We really started that with docks, you know, where people, you know, where whaling was the main industry in 1695. When then Brunel came along in 1843, that's when we get the sort of the Thames Tunnel. We then get the Victorian super sewer, Bazalgette's super sewer, and then really we're sort of moving into the timber trade. But we're really getting in these sort of times. So fast forward really to the Canadawater redevelopment, you know, so we're really moving it from a dockland area to an area where Hannah's explained, we're sort of having people and work and a completely different landscape, and yet exactly in the same location. And this original Thames Tunnel and the Victorian super sewer, Bazalgette sewer, is actually now being upgraded and redone as the Tideway Tunnel, both of which we're expecting to actually be available to us today in 2024, and of course the Canadawater completion in 2035. So just in this time scale, the engineering skill underpinning very similar, but yet so extremely different and developed from what we know. So if you take the next slide, I just wanted to highlight really, if you were to look up at sort of the new jobs that didn't even exist 5 years ago, you'd find all of these things, all of which affect engineering just the same. We have got data scientists and engineers, you know, a new job, something that wasn't even in existence. Cloud architects, mobile app developers, social media managers, community managers. And I've just sort of extracted here a quote for you on the right, where it says about the big data industry. That is statistically what a study on LinkedIn found was the data mining analysis type aspect of these jobs were the second most demand in skill for every job posted on LinkedIn by employers in job advertisements. So going back to this slide before, where you thought about this journey of Canadawater alone, you just see some of these emerging skill requirements that are actually coming through. And the final slide, please, for me. And this is a skills review where really the various engineering professions, this one happens to be the Institution of Civil Engineers, and sort of links a little bit with Brunel, and it links also a little bit with what Hannah was talking about, the Canadawater redevelopment and some of the points I've made. But really, it's not just about building things, yeah, but it's also about operating and maintaining this. It's about renewal, adaptation, and decommissioning when we're done an upgrade. And then it's about this really important aspect. And Sarah made a point to that actually early on, which I thought was really interesting. In the new era of engineering, specialization wasn't really a thing. And we went really into silo knowledge. And we're now finding that with these emerging skill sets, with this new requirement on what engineering looks when we look into the future, we're actually finding we're working across multidisciplines, across boundaries, and we're really having to do much more work around stakeholder and engagement. And we're doing all of this with enhanced ways of actually having data at our hands. Yes, Brunel had data, but they did not have data to the extent that we have. And Steve and I were sort of working with a stakeholder the other day who said to us that we are generating more data a day than we generated in the totality up to the year 2000. So that just shows you that data and digital technology is becoming the future of engineering. And this is really where some of those supportive skills will come from. I will stop here, but I hope it's given you some sort of food for thought, but also to get our discussion kick-started once Rosanne has given us her perspective. So I look forward to all of your comments in a minute. Thank you.
Thank you very much, Julie. And as Julie's mentioned, for our final presentation from Rosanne.
Hi, so I thought I'd just tackle some of these questions on the slide here. Just discussing the projects we worked on. So the one we just finished was for Engineers Without Borders UK, and it was looking at the Cape York area in Australia. And our research included lifestyle of inhabitants, transport and weather, technology, and we had to take the inhabitants' attitude into account as well, something that you wouldn't ordinarily think of, but due to the area and the way they look at their land, it was very important. Our group chose to focus on reducing the waste, the marine waste problems they have, with a view to improve their livelihoods and environmental systems. The area is very close to the barrier reef, so a lot of marine life was at stake. We discovered, and this was surprising, that the main source of the waste was not from their area, but from countries like Papua New Guinea and Indonesia, because of the way the sea currents are and their location. All the waste ended up on their shores, and that made us realize what global impact really means, as you know, one country has such a large impact on another. But then we thought we'd turn it on its head. Rather than seeing it as an issue, we thought we could treat the waste as a valuable resource, and created a model where we could take pet waste, buy it from local recycling centres in Cape York, and it would be pre-washed, packaged, and then we could reuse it in a manufacturing process done in other parts of the world to produce polyester material, and that could be made into garments or sold on rolls, and create a new industry for the people, optional if they wanted to, but also with a view to maybe replacing the existing mining situation they have. They're full of emissions going on. The thing we realized was for some things to change, you need to show alternatives, and they have to be easy to implement, with costs taken into account, so governments, you know, can just tick them off, and if they satisfy employment, education, and getting income for the society. So that whole project from start to finish was very interesting because it brought in so many different aspects of life, not just, you know, the way you would normally consider an engineering project to be, you know, and also it was, you know, sort of the other end of the world, and yet you could, you know, think about all these things from this end and be able to realize something that could be good, or provide a solution for what was an issue there. The next question was, how much responsibility do you think you and your peers will have for tackling the challenge of climate change? And I think a great deal, because the average person, we think, doesn't have a full understanding of the science, technology, and processes that go into most of the infrastructure and materials they use, whether it be the construction of buildings, manufacture of plastics, food technology processes in oil and mining, and even temperature regulation. So engineers have always focused on the end products, and there's always been an agenda of how quickly and cost effective they could be obtained, to actually understand what waste products and emissions were created in all these processes. It wasn't high on the priority list. Also, buildings have been done to economical rather than environmental agendas. And now there's a massive retrofit that has to take place to reduce all these emissions. So more engineers are going to be required to do this. I think we're on a tight deadline, and there just seems not to be enough engineers coming into the industry or students for all that, because the global task has become so big now. And it will be the engineers that understand the issues and how you can implement these things and have the resolutions for the better future. So I think it's a huge responsibility for the sector. Let's go to the next question. When developing a new product or solution, how early on in the process should these issues be considered? Well, again, it's always been an afterthought throughout history. And I think now we're paying the price. Humans, whenever they create any type of infrastructure, they've been proud of what they've done. You know, obviously it's been safe for humankind, but the impact on the environment has always been secondary. And we've got to start thinking about these, you know, before the design happens. For example, site location has a huge impact on the environment and the people living there. And emissions and byproducts, they're all part of that. So it has to be, even in this drawing up stage, the thinking stage. Let's go to the next question. What are your views on the current discussions being held at COP26? Yeah, so I think in any affair, when you have an important deadline to meet, you would make sure you're well within that deadline. And then you would try and overachieve on the objectives if it's really important to you. And I feel in COP26, the way that I see the leaders behaving really makes me feel they're not attaching that much importance to the future of the planet. There are protests, and I think those have been good throughout history and have been instrumental in bringing about change. But I think the leaders were different then. I don't see any disaster recovery plans for countries. There's no transparency of that, especially in the areas of low-level lands on the coastlines. They know that the sea levels will rise. And where are all these people going to migrate to? They need to, shift them to better locations, and what costs. The seawater has already made freshwater supplies for crops redundant. So vast areas of farming have to be relocated, and this has an effect on food supplies. It's going to be scarce there. And we've seen on the news that villages are being relocated away from coastlines. But this is this is a really important a point, because engineers are going to be required to do all this. There has to be a global plan, and it can't just be temperature and emissions focused. We need to look at disaster recovery and start working on target areas where we know we can't avoid an impact. I think engineers are going to be fully involved in this, and I think the role of an engineer will be even more important one in the future. Sorry, I went mute there. Did you catch the end of that?
I did, sorry. I was chatting away and I was on mute.
I'm sorry.
Thank you to everybody, to all our panelists and presenters. Thank you for all of your thoughts and interesting elements there. I know it's really difficult on such a big topic to cover all the different things that you'd like to in such a kind of space. So I really appreciate how you all condense that into particular elements. But now is the opportunity for those of you that attended, the participants, for this event to ask your questions. If you want to drop those in the chat, we have a few of you, but I guess if you want to put your hand up or unmute and ask a question, then fire away. I'll give you a couple of minutes to write in the chat. I mean, I had just a kind of couple of questions on things that are around there as well. But Julie, I think you'd mentioned things that you had questions for other panelists as well. So happy to let you go first rather than jumping in if you wanted.
Yeah, no, brilliant. I mean, one of the questions I actually had for both for Sarah and Hannah, but if we maybe start with Hannah, and that was about you know, sort of how, you know, and you've shown us quite a few sort of examples of how this sustainability drive is instrumented and is sort of laid down, operationalized, as it were, within your day-to-day practices. And I was just wondering about your observations of how engineering interfaces with that, and yeah, maybe from your own experience, how that may have changed in sort of whilst you in your work life, you know, but whether there is a change that you've observed as well.
Yeah, well, I mean, engineers are absolutely crucial to us being able to meet the targets that we set out. You know, without them and without lots of collaboration with them, there's no way we'd be able to get to net zero. And I think there's been a huge change in the last 5, even in the last 2 or 3 years, around how engineers are thinking about sustainability and thinking about carbon and thinking about the impact of development. It used to be sort of a bit of an afterthought. It used to be all about cost, time, and quality, and now it's totally shifted, and it's still about cost, time, and quality, but carbon is in that mix as well. I think it's led to a much more balanced approach to engineering and to architecture and to design generally. And to be honest, it makes it a much more exciting industry to be in. I've like really enjoyed the last couple of years because we're just looking at things totally differently. So it's really exciting. And I think the engineers have really embraced the challenge, and I think we all recognize that everyone's on a bit of a steep learning curve, and so everyone's sort of heads down working together in a really collaborative environment. So yeah.
Yeah, thanks for that, Hannah. I think it's just so important to bring that out. And again, it's sort of then sort of looped around back to Sarah for me, because Brunel was an innovator and inventor in his time. You know, the whole family actually was, you know, they were real. And whilst, you know, the sustainability aspect of it wasn't necessarily, not necessarily the main, you know, the main driver at the time, there was still a real consideration of that. But I guess, Sarah, from your knowledge of the Brunels in the past, but also you taking up your own more detailed work in sort of the engineering field yourself, I guess I just wanted to sort of get a sense from you. And I see, Steve, there is also a question coming from the panel, from the group. So I'll shut up after that. Thank you.
So I think money was definitely a major driver in the Industrial Revolution, much like it has been all along. So whilst people were occasionally doing things that we would look at and go, oh, that is rather environmentally conscious, that is surprising. So things like the clay that was dug out from the Thames Tunnel was then used to make the bricks that were taken back down to line the Thames Tunnel. So you have all of these little bits of industry, the economies of scale moved away. And engineering now, you're going back and looking at a lot of things and seeing how we can do things differently and seeing how we can be more efficient and less harmful. But now we're doing it to try and not destroy the earth rather than because it's cheaper that way. though it does help that a lot of these solutions are actually cheaper.
Yeah, it's the virtual circle we call it, don't we? You know, if you're doing well by the people and you're doing well by the money and you do, you know, it sort of should work its way through. I'll stop here. I think, Steve, there is a...
Yeah, I was just going to say, it's interesting, isn't it? It's those economical models, and I know Roseanne mentioned that as well, of and obviously that come in some of the talks that they'd have, and obviously the clay element, that's why wouldn't you reuse it? It economically makes sense until something's cheaper. So it's interesting how those always drive. I will ask this question too. I don't, unless anyone particularly wants to take it. I was wondering if Hannah had a thought on this, but if anyone else, particularly from the panel, wanted to jump in, then do let me know. So the question was, Brunel did a great deal of work where Fiona lives in Bristol, but never any tunnels. The current mayor has his heart set on an underground. Is that an unsustainable pipe dream for a coastal city, or the scale of ambition needed to get people out of private cars? So I don't know if Hannah, if you wanted to take that, because I know there's also the transport consideration in terms of things that you do for the master plan. So I wonder if what your thoughts were on that.
Yeah, I think it's an interesting question. I think we'd need to do whatever we can to get people out of private cars in cities in particular, or at least be getting people to electric cars, but ideally just getting them off the road altogether. So I think an underground could be an interesting proposition for Bristol. I don't know enough about Bristol to know whether it's a sensible proposition for that particular place, but you know, cities are still growing. I know the pandemic did put the brakes on a little bit, but I think cities are always going to be places where people come and live and work, and they're only really going to grow in the long term. So something like an underground could be a sustainable way to do that, definitely.
Cool, thank you, Hannah. There's one more question, and I'm also very conscious of time. Did anyone else want to comment on that thought of underground in sort of Bristol, or shall? No. Sarah looked like she was going for the mute button. I will ask the sort of next question here. It was reminding me of something else around the Brunel Museum, but I will save that. So anyone particular views on HS2? I'm guessing that as a impact that it has, benefit that it has. Julie, you're nodding your head. Any particular thoughts as a project?
No, I just agree, Ted. I will not actually venture out and put my hat in the ring as to where I think it is or isn't, because the debate that we see played out in the public realm around, you know, the benefits of HS2 versus, you know, is it really worthwhile, you know, reducing 10 minutes worth of train time for all of this disruption that we're putting to it, and for me, I do think this sense of debate of really measuring and agreeing on how to measure is ever so important, and this interplay, and COP26 is a perfect canvas for this as well, the interface between, you know, scene setting and national agenda, you know, to sustainability and what it can do, and ensuring that people don't travel as much because actually they have hubs all over the country, so they don't actually need to travel, you know, all of that sort of playing into it. So there's no short answer. I just yeah, but you hit the head right head. This is a very prime example of an engineering contribution that needs to be looked at the light of sustainability and how it helps overall. So, you know, that was just my quick comment. Brunel didn't have that problem, is all I'm going to say.
I think that's it. But having said that, I don't know if Sarah's on this, because I know from having conversations of there was something on there's ramps for the tunnel, because it was meant to have horse-drawn carriages, but then that actually never came through. So the success of the tunnel wasn't seen until quite a long time afterwards. So the
tunnel was considered a failure when it first opened, because the whole reason for building the tunnel was because the Thames, which you might find hard to imagine now, but the Thames was chock-a-block full of ships that wanted to unload their cargo. And you really didn't want to unload on the south side if all your cargo was going north, because getting across the river was awful. There was London Bridge, which was a constant traffic jam. And the river itself was a traffic jam. So it could take you months to just get up and down the Thames. Like, it literally would take some captains longer to get up and down the Thames than it took to get across the Atlantic. So this is the scale of problem you have. So a tunnel, the idea for a tunnel was so that you would be able to get goods from one side of the river to the other further east than you could build a bridge, because you had to be able to get the tall ships west along the river, so you couldn't build a bridge in the way. So obviously Tower Bridge is a generation later. So when they ran out of money and they couldn't build ramps, so you couldn't get horses down into the tunnel, it was considered a failure. It was considered an amazing tourist attraction, but not really any use. And it wasn't until 20 odd years later that it was taken over by trains that it was really useful. But we really wouldn't want to be without it now. Thousands of people use it a day, even in COVID times. So you do always have to think about the long-term uses and impacts of any scheme. And I have all the thoughts about HS2, but they are very complicated and it's not the time to go into them.
So we will wait and see on HS2, and from the sounds of it, if you go down to the Brunel Museum, I'm sure Sarah will share with you the views on that if you got a bit of time in the afternoon. So I will just finish off with the last question, because obviously this is interesting and important for a number of people on the call. So Laurie asked about, is there a particular pathway the panel would recommend for getting into the environmental aspects of the engineering industry, or resources to look into this further? So any resources that anyone can recommend, or pathways around environmental aspects of the engineering industry?
Yeah, I would just quickly say, I mean, all of the institutions' website, be it the civil engineers, be it mechanicals or the IET, there is dedicated stuff. The Royal Academy of Engineering has got really good information on, you know, engineering sustainability, the future skills of engineers, and what is needed to make this transition happen. So that's always a very good start. And of course, we at TEDI will also be delighted to hear more, and there will be regular updates from us as well as we sort of venture through some of these topics. As Roseanne has shown, it is really center stage for some of the work we're doing at TEDI with the students as well. So yeah, that would just be my recommendations.
Thank you. There's some additions in there as well. Thank you, Fiona, for adding that in. Is there anything anyone else on the panel would like to add in terms of particular resources to look at, or maybe things to sign up in terms of pathways and information?
The UK Green Building Council is a really good resource as well, and they have lots and lots of events and lots of courses that you can sign up to, where you get sent coursework each week, and that's I've found that quite useful. And also just asking questions and trying to talk to people is always. I find I learn the most when I just ask stupid questions.
Excellent. Thank you ever so much, Hannah. I'm going to bring the event webinar to a close. Just like to thank once again all the panelists, but also all the attendees, and for the questions. Thank you all ever so much. Sorry, I slightly ran over by 5 minutes or so, but I hope you all found it